Good morning, everyone. I am Himani Vishwakarma, student of IIPS DAV Indore, and today my topic is Boolean function and synthesis of circuits. Boolean function. Boolean function are used in synthesizing digital circuits where the goal is to create a circuit that perform a specific logic experiences. The process involving transforming Boolean expressions into a physical circuit composed of logic gates such as AND or NOT, NAND, NOR, and XOR gates. Boolean function. A function f a belongs to a is called Boolean function if it can be specified by Boolean expression of n variable. Boolean algebra is a branch of algebra in which value of variables are truth value, true or false, usually denoted by 1 or 0. Let a equals to x1, x2, x3 up to xn. Type of Boolean functions. Boolean functions are of many types. The mains are AND function, OR function, AND function. The AND function returns true 1 if and only if all its input variables are true, means 1, otherwise it's written false, 0. It can be represented symbolic as f equals to a dot b or f equals to a and b. OR function. The OR function returns true 1 if at least one of its input variable is true. Then it represents as 1. Otherwise, it returns false 0. Symbolically, it can be represented as f equals to a plus b or a b. Boolean algebra is a category of algebra in which the variables value are the truth value, true and false, ordinarily denoted 1 and 0 respectively. It is used to analyzing and simplify digital circuits or digital gates. It is also called binary algebra or logical algebra. It has been fundamental in the development of digital electronics and is providing for in all modern programming languages. It is also used in set theory and statistics. The important operations performed in Boolean algebra are conjunctions, disjunctions, and navigations. Hence, this algebra is far way different from elementary algebra, where the values of variables are numerically and arithmetically operations like addition, subtraction is performed on them. Boolean algebra operations. The basic operation of Boolean algebra are as follow: conjunctions or AND operation, disjunctions or OR operation, navigation or NOT operations. Below is a table design the symbol for all three basic operations. Suppose a and b are two Boolean variables, then we can define the three operations as a conjunctions, b or a and b satisfied a and b. True if a equals to b, true, or else a and b equals to false. A disjunction b or a or b satisfied a or b, which is equals to false if a equals to b is false, else a or b is true. Navigation a or navigation a satisfy a navigations equals to false if a is true and a navigation is false if a is false. Boolean expressions. A logical statement that result in Boolean value either be true or false in a Boolean expressions sometimes are used to express the sentence such as yes or true and no or false. Also 1 and 0 used for digital circuits for true and false respectively. Boolean expressions are the statements that use logical operations, therefore AND or XOR are not. Thus, if we write x and y true, then it is a Boolean expressions. Boolean algebra terminologies. Now let us discuss the important terminology covered in Boolean algebra. Boolean algebra is a branch of algebra that deal with the logical operation and binary variables. Boolean variables. A Boolean variables is defined as a variable or a symbol defined as a variable or a symbol, generally an alphabetical that represent the logic quantities such as 0 or 1. Boolean function. consist of binary variables, logical operations, constants such as 0 and 1 equal to the operators and the parenthetical symbols. Truth value or truth table is a table that gives all the possible value of logical variables and the combination of the variables. It is possible to convert the binomial equations into a truth table. The number of rows in the truth table should be equal to 2 to the power n, where n is the number of variables in the equation. For example, if a Boolean expression consists of 3 variables, then the number of rows in the truth value is 8. 2 to the power 3 equals to 8. Boolean algebra's rules. Following are the important rules used in Boolean algebra. First, variable used can have only two variables, binary 1 for high and binary 0 for low. The complementary of variable is represented by an over bar, which is equals to 0. Or of the variable is represented by the plus sign between them. For example, the OR for A, B and C is represented as A plus B plus C. Logic AND for the two or more variable is represented by returning a dot between them, such as A dot B dot C. Sometimes the dot may not be omitted like ABC. Laws of Boolean algebras. There are 6 types of Boolean algebra laws. They are commutative law, associative law, distributive law, AND law, OR law, and inversion law. Commutative law and binary operation which satisfy the following expressions is refers to as a commutative operation. Commutative law state that changing the sequences of the variable does not have any effect on the output of the logic circuits. Associative law. It states that the order in which the logic operations are performed is irrelative as their effect is the same. Distributive law. Distributive law state that the following condition, which A dot B plus C, which is equals to A dot B plus A dot C. AND law. This law used the AND operation, therefore they are called AND laws. Or law. The OR law used the OR operations, therefore they are called OR laws. Inverse law. In Boolean algebra, the inverse law state that the double inversion of variable result in the original variable itself. Boolean algebra. The two important theorems which are extremely used in Boolean algebra are De Morgan's law, De Morgan's first law, and De Morgan's second law. These two theorems are used to change the Boolean expressions. The theorem basically helps to reduce the given Boolean expressions in the simplified form. These two De Morgan's law are used to change the expression from one to another form. Now let's discuss about the theorems. De Morgan first law. De Morgan first law states that A dot B dash equals to A dash plus B dash. The first law states that the complementary of the product of the variable is equal to the sum of their individual complementary of a variable. Thank you.